AS students, in this session we are gonna go for rate of change, chapter 8, differentiation. Rate of change is actually giving you the ratio between two concepts, two quantities actually. How much one of them is changing as time is changing. So when you are gonna use rate of change, so one of the variables is time, which is changing. Now, as you have already learned in physics, those students who are taking physics, they already know that. For example, when you are going to find velocity, velocity is rate of change in displacement over rate of change in time, which is ds over dt. So it's a kind of rate of change. The other thing, acceleration or deceleration, rate of change in velocity over rate of change in time. So it is another rate of change. So you have been already using rate of change in your real life even. Now let's go to the first example. Example 8.9. Just remember one point. Let's review when we learn differentiation. Differentiation actually gives you gradient. You all learned at the beginning of this chapter, which gives you gradient. What is gradient? Rate of change in vertical change or increase in height or decrease in height over rate of change in horizontal axis. So vertical change over horizontal change, which is the type of rate of change. But in that case, it is dy over dx. But now in rate of change, we just focus on rate of change with respect to time. So your denominator is always time. Now look at the first example here. It says given that h is equal to 1 over 5 t squared, find the rate of change of h with respect to t when t is 2. As you see, fortunately, h is directly defined in terms of t. So you can easily differentiate. What is differentiation of h is equal to 1 over 5 t squared? So you bring the power down, so it will be 2 over 5, and you subtract 1 from the power. So it will become 2 over 5 t. When it says when time is 2, so time is 2, it will be 2 over 5 times 2, which is 4 over 5. So what does this 4 over 5 mean? It means that when t changes 1 unit, h will change 4 over 5 units. Now, let's see the other example concerning rate of change. It says variables v and t are connected by the equation v is equal to 2t squared minus 3t plus 8. Find the rate of change of v with respect to t when t is 4. Now, again here you are clearly seeing that v is defined in terms of t. So again, differentiate. So differentiation of dv with respect to time, it will be 4t. You bring power down, it will become 4t. Differentiation of minus 3t is minus 3, and 8 is constant. Differentiation of constant is 0. And it says when time is 4, so replace 4 in the differentiation formula, which gives you 4 times 4 minus 3 gives you 13. So it is a rate of change of v with respect to time here in this question is 13. Now, next topic, it says when two variables x and y both vary when a third variable t is changing. Now, it is here we should implement actually chain rule, because both x and y are connected with each other, and x is changing as time is changing, y is changing as time is changing. So we here we are looking for dy dt. Y is expressed in terms of x. So I differentiate, I write dy over dt is equal to, but we know that y is expressed in terms of x, so we have to differentiate with respect to x first. But multiplied by, I don't want dx here, so I multiply by dx over dt, as if dx cancel out each other. Dy dt is remaining. It's exactly what we want. So dy dt, when you are differentiating with respect to a third variable, you use this formula. remember this formula. Let's go for an example. It says that a point with coordinates x and y um, moves along the curve y is equal to x plus radical 2x plus 3 in such a way that the rate of increase of x has the constant value 0.06. So it is saying that rate of increase. So it means that first it is positive as it is increase, and it says rate of change in x. So it is dx. This quantity is dx dt, 0.06 per second. Now find the rate of change, rate of increase actually, of y at the instant when x is 3. State whether the y coordinate is increasing or decreasing. So again, I just changed the form. X is equal to, y is equal to x plus 2 x plus 3 to the power of 1 second. Now, to make it easier to differentiate. So I differentiate dy with respect to x. So it is 1 plus power comes down. Differentiation of interior expression 2x plus 3, which is 2, is written here. Then subtract 1 from the power. It would be 2x plus 3 to the power of 1 less. But times here, it should be multiplied by dx dt. So and x is 3. It says as instant at the instant when x is 3. So dy dx will be equal to, here you see here 3 is initially substituted, but this formula must be used. Dy dt is dy dx times dx dt. So what was dy dx? This formula, in which x is substituted, because x was 3, it is substituted and it gives you 4 over 3. It's written here, times dx dt. Dx dt is given 0.06, so it will be 0.08. As it is positive, so it will be increasing. Thanks for watching this video.